Next type of reaction is displacement reaction. Those reactions in which one element takes the place of another element in a compound are known as displacement reaction. In general, a more reactive element displaces a less reactive element from its compound. Example: when a strip of zinc metal is placed in copper sulfate solution, then zinc sulfate solution and copper are obtained. In this reaction, zinc displaces copper from copper sulfate compound so that copper is set free or liberated. The blue color of copper sulfate solution fades due to the formation of zinc sulfate, which is colorless. A red-brown deposit of copper metal is formed on the zinc strip. Please note that this displacement reaction takes place because zinc is more reactive than copper. I have given some reactivity chart, so just go through that so that you'll understand which all metals are more reactive as compared to other metals. So that will make a reference for you so as to understand the reactivity in the reaction. Next example, when a piece of magnesium metal is placed in copper sulfate solution, then magnesium sulfate solution and copper metal are formed. In this reaction, magnesium displaces copper from copper sulfate solution. The blue color of copper sulfate solution fades due to the formation of colorless solution of magnesium sulfate. A red-brown deposit of copper metal is formed on the magnesium piece. Here, magnesium is able to displace copper from copper sulfate solution because magnesium is more reactive than copper. Next example. When a piece of iron metal, say iron nail, is placed in copper sulfate solution, then iron sulfate solution and copper metal are formed. In this reaction, iron displaces copper from copper sulfate solution. The deep blue color of copper sulfate solution fades to the formation of light green solution of iron sulfate. A red-brown coating of copper metal is formed on the surface of iron metal. So please note that this displacement reaction occurs because iron is more reactive than copper. Next example. When a strip of lead metal is placed in a solution of copper chloride, then lead chloride solution and copper metal are formed. In this case, lead displaces copper from copper chloride. The green color of copper chloride solution fades to the formation of colorless solution of lead chloride. A red-brown layer of copper metal is deposited on the lead strip. So it indicates that lead is able to displace copper from copper chloride solution because lead is more reactive than copper. Next example, when a copper strip is placed in a solution of silver nitrate, then copper nitrate solution and silver metal are formed. In this case, copper displaces silver from silver nitrate compound. Thus, this displacement reaction occurs because copper is more reactive than silver. A shiny grayish-white deposit of silver is formed on the copper strip and the solution becomes blue due to formation of copper nitrate. Next example, iron metal reacts with dilute hydrochloric acid to form iron 2 chloride and hydrogen gas. Iron 2 chloride means FeCl2. In this reaction, iron displaces hydrogen from hydrochloric solution to form hydrogen gas. So it indicates that iron is more reactive than hydrogen. Magnesium metal reacts with, next example, magnesium metal reacts with hydrochloric acid to form magnesium chloride and hydrogen gas. In this displacement reaction, magnesium displaces hydrogen from hydrochloric acid solution. This displacement reaction occurs because magnesium is more reactive than hydrogen. Example 8. Sodium metal reacts with water to form sodium hydroxide solution and hydrogen gas is released. So this displacement takes place because sodium is more reactive than hydrogen, as you can see in the chemical reaction mentioned. Next example, chlorine gas reacts with potassium iodide solution to form potassium chloride and iodine. So this displacement reaction occurs because chlorine is more reactive than iodine. Most of the common displacement reactions occurs in aqueous solution, that is water solutions. There are, however, some displacement reactions which also occur between solid substances. The displacement reaction of metals with metal oxides are such reactions. Please note that a more reactive metal displaces a less reactive metal from its oxides. This will become more clear from the following examples. And hence I have given more and more examples so that you can identify how the nature, how all elements behave in the different type of reactions. When copper oxide is heated with magnesium powder, then magnesium oxide and copper are formed. Copper oxide plus magnesium gives magnesium oxide plus copper. So in this displacement reaction, a more reactive metal, magnesium, is displacing a less reactive metal, copper, from its oxide, that is copper oxide. When iron 3 oxide, that is Fe2O3, is heated with aluminium powder, then aluminium oxide and iron metal are formed. In this displacement reaction, a more reactive metal, aluminium, is displacing a less reactive metal, iron, from its oxide, iron oxide, that is iron 3 oxide to be precise. Please note that so much heat is produced in this reaction that iron is obtained in the molten state. We will now describe another type of displacement reactions called double displacement reactions. Now, those reactions in which two compounds react by an exchange of ions to form two new compounds are called double displacement reactions. A double displacement reaction usually occurs in solution, and one of the products, being insoluble, precipitates out, separates as a solid. So some of the examples of double displacement reactions are given below. First, when silver nitrate solution is added to sodium chloride solution, then a white precipitate of silver chloride is formed along with sodium nitrate solution. Now listen the description carefully. In this double displacement reaction, two compounds, silver nitrate and sodium chloride, react to form two new compounds, silver chloride and sodium nitrate. An exchange of ions takes place in this reaction. For example, the silver ion Ag plus of silver nitrate react with chloride ions Cl minus of sodium chloride to form a new compound, silver chloride Ag plus Cl minus or AgCl. Similarly, the sodium ions Na plus of sodium chloride react with the nitrate ion NO3 minus of silver nitrate to form another new compound, sodium nitrate, that is Na plus NO3 minus or NaNO3. Please note that in the above double displacement reaction, silver chloride is formed as an insoluble white solid called white precipitate. Second example, when barium chloride solution is added to sodium sulphate solution, then a white precipitate of barium sulphate is formed along with sodium chloride solution. In this displacement reaction, two compounds, barium chloride and sodium sulphate, react to form two new compounds, barium sulphate and sodium chloride. An exchange of ions takes place in this reaction. For example, the barium ion Ba2 plus of barium chloride react with sulfate ions to SO4 2 minus of sodium sulphate to form barium sulphate, that is Ba2 plus SO4 2 minus or BaSO4. In this reaction, barium sulphate is formed as a white insoluble solid that is precipitate, which separates out suddenly from the solution. So any reaction in which an insoluble solid called precipitate is formed that separates from the solution is called precipitation reaction. The reaction between barium chloride solution and sodium sulphate solution to form barium sulphate precipitate along with sodium chloride solution is an example of precipitation reaction. If barium chloride solution is added to copper sulphate solution, then a white precipitate of barium sulphate is produced along with copper chloride solution. So in this double decomposition reaction, two compounds, barium chloride and copper sulphate, react by an exchange of their ions to form two new compounds, that is barium sulphate and copper chloride. Next example, when hydrogen sulfide gas is passed through copper sulphate solution, then a black precipitate of copper sulfide is formed along with sulfuric acid solution. In this double displacement reaction, two compounds, copper sulfate and hydrogen sulfide, react by an exchange of ions to form two new compounds, copper sulfide and sulfuric acid. When ammonium hydroxide solution is added to ammonium chloride solution, then a white precipitate of aluminium hydroxide is formed along with aluminium chloride solution. So in this double displacement reaction, two compounds, aluminium chloride and aluminium hydroxide, react by an exchange of their ions to form two new compounds, aluminium hydroxide and ammonium chloride. Next example, when potassium iodide solution is added to lead nitrate solution, then a yellow precipitate of lead iodide is produced along with potassium nitrate solution. Kindly note that whatever compound you are just seeing, that you have to remember. So you'll see lead nitrate, the PbNO3 twice, this you'll have to remember, because they are formed based on their valencies. Okay, so this is also a double displacement reaction. In this double displacement reaction, two compounds, lead nitrate and potassium iodide, react by an exchange of ion to form two new compounds, lead iodide and potassium nitrate. Please note that lead nitrate, PbNO3 twice, is also written as lead 2 nitrate. Next example, the reactions between acids and bases to form salt and water. Note this statement, the reactions between acid and bases. Acid and bases always react to form salt and water. So the reactions between acid and bases to form salt and water are also double displacement reactions. For example, sodium hydroxide reacts with hydrochloric acid to form sodium chloride and water. So in this double displacement reaction, two compounds, sodium hydroxide and hydrochloric acid, react by an exchange of ion to form two new compounds, sodium chloride and water. Please note that no precipitate is formed in this double displacement reaction.